here. Okay, so the other important concept is impulse. And I'm sure if you had high school physics, you've heard of impulse and the impulse momentum theorem. Impulse is just a change in momentum. And it is literally a momentum. It is the same units. We call it J, big J. It's also a vector. It's the same units, and it's in kilogram meters per second. If we were treating it like velocity or position, we'd just call it delta P. It is just delta P. But for some reason, it's so fundamental, since it has to do with Newton's laws, we give it its own name and call it impulse. Okay? So what we want to do is look at how we can calculate this, or what it's related to in terms of the forces that create it. Right? A change in momentum, J, it must take a force to make it. So let's sort of derive a little bit here. Let's start with velocity, with the velocity-acceleration relationship. And we're going to do it two ways, because some of you like calculus, like 2 of you like calculus, and the rest of you don't. So let's do constant acceleration. So if you had constant acceleration, thinking back to kinematics now, we had that delta V equals acceleration times delta T. Right? If you say, wait a minute, in kinematics, there were only 2 equations. There was x equals x naught plus VIT plus 1 of AT squared, and V equals V naught plus AT. Well, this is V equals V naught plus AT, right? V naught minus VI brings it over here. You know, that's what that is. If you have what I'll put in physics, we like to say in general, you know, if A is not constant, in any case, the delta V would be the integral from T1 to T2 of A, which might be a function of time, dt. There's a scary version there. Right? If A is constant, then it just becomes, you integrate AT, T2 minus T1 is delta T. There you go. But if A is going to change on you, which it is in collision problems, but we have a way of blowing that off, then you got to deal with it. Okay? So part 2, multiply by the mass is all we got to do. Multiply by the mass, and you say, what? M times delta V. Well, mv we know is P. Right? So we get that delta P is mass times acceleration times delta T. That's a crappy T there. Right? And over here, multiply through by M. Delta P, this thing. Oh, it's the integral from T1 to T2 of mass times acceleration times dt. Interesting. Right? And number 3, step 3, use the force. Yes, that's clearly a force there. Insert your own Star Wars joke here. You've all seen the coffee cups and the t-shirts. May the F equals MA be with you. I do not need another one, if you were thinking of getting me one. It's okay. I think it's funny. I laugh every time I read it, but I've got many, many coffee cups and t-shirts that say that. You can get me something else. That's okay. We're grading Wednesday. Okay. So we're going to use force here, and we're going to realize, oh, delta P is just J. All right? So J equals delta P, but now we say, oh, well, that's just the force, F delta T. Okay? So we just kind of went from some basic kinematics, multiplying by M kind of makes it physics, and that's how we see that this impulse, in addition to being the change in momentum, delta P, it's equal just to the force applied times delta T. Now, if the acceleration was constant, that would also imply that that force is constant. All right? What if the force isn't constant? Well, then we come over here. Then we say this J also equals delta P. We could say it's the integral of the MA of the force over time. Right? Now, I know this might be getting too low. F dt. Okay? So these are kind of the equations, the ones you would use here when you're dealing with impulse. You either multiply a constant force times a delta T, or you integrate to get force's total change over delta T. Right? Okay, so now we have it defined. Now what are we going to do with it? Okay, so we're going to look carefully at impulse, and there's another book. So Newton's book is about momentum. I actually found another book about impulse. Here it is. It's called Impulse. and it's by Stephen Gould. Scent has a secret. Okay? She lives in isolation with her parents. Okay, that's not really possible. Let's keep going. Isolation with her parents, hiding from the people who took her father captive and tortured him to gain control over his ability to teleport. Okay, it's sci-fi. Okay. And from the government agencies that want to use his talent. Sin has seen the world, but only from the safety of her parents' arms. She's teleported more than anyone on earth, except her mother and father. But she's never been able to do it herself. Her life has never been in danger. Until the day she went snowboarding without permission and triggered an avalanche. When the snow and ice thundered down on her, she suddenly found herself in her own bedroom. Boom, she teleported. Oh my God, I have got to read that book. That was the first time. Okay, so what we're going to do is we're going to go through what happened to Scent up until the moment that she teleported, okay? And we're going to do that as the problem. If you're ever giving a presentation and you need to fill in a little something or other, take the subject of your presentation, put it in Amazon Books, and you'll have a good 30 seconds, okay? You can also do movies. I did movies, but they were a little too spicy for 125, if you know what I'm saying. Movies called Impulse were kind of a problem.